go over, it demonstrates conservation of heat, and it states after getting decides that the 0.6 kilogram coffee, which is made of mostly water, is way too hot at 90 degrees Celsius. She decides to add cold milk to her coffee. If the specific heat of milk is 3,987, what is the final temperature of the coffee? So the way that you approach these problems is you think of it as a heat loss and heat gained. And according to our laws of thermodynamics, the heat lost plus the heat gained is going to equal to 0. So the first thing you got to ask yourself is, between the milk and the coffee, who is going to lose the energy? Who is going to gain the energy? Think of this like who's going to get colder, who's going to get hotter. In this particular example right here, I'm going to say that the coffee is going to lose the heat and the milk is going to gain. So what you want to do is you want to ask yourself, will the coffee just change in temperature, or will there be some phase change action? All right, we're going from 90 and we're adding just cold milk, which is also in the liquid phase, so chances are it's only going to undergo a temperature change. So this energy loss can be calculated by using the MCAT formula. Next, you look at your milk and ask yourself, is the milk going to undergo a phase change? Well, chances are it's not going to. It's not going to get hot enough to turn into steam. So this energy will be calculated also by using a phase change. A temperature change. So what we want to do now is start plugging in our numbers where they belong. Okay? The mass of the coffee was given to us at 0.6 kilograms. The specific heat of coffee, since it's made mostly of water, is going to be 4,187. And the temperature change of the coffee is going to be ultimately what we're looking for, but specifically we're looking for the final temperature of the coffee. Now the initial temperature of the coffee is given, and that is 90 degrees. Okay. This is how to calculate the energy of the heat lost by the coffee. And remember that if you leave your coffee sitting there long enough, eventually the coffee and the milk will have the same final temperature. They reach equilibrium. All right, to this we're going to add the energy gained by the milk. So the mass of the milk is 0.03. The specific heat of the milk is 3,987. And then that temperature change, once again, that's our TF. We don't know what that final temperature is, minus the initial temperature of the milk, which wasn't given in the problem. That's my mistake, but I'm going to go ahead and put it at 5 degrees. Now, the easiest thing to do at this point is to simplify. All right, so the first thing that I'm going to do is to multiply these two numbers together. Then I'm going to multiply the two numbers together, and I'm going to rewrite my equation with those numbers multiplied out. So I've got 0 equals 2512.2 TF minus 90 plus 119.6 TF minus 5. Okay, so all I've done is take this long equation here and simplified it a little by multiplying those two numbers. Next thing I'm going to do is I'm going to do some distributing. Okay, I'm going to distribute this number into this parentheses and then this number into parentheses, and I'm going to rewrite my equation to kind of simplify it a bit. So 25.1.2 Now I'm going to distribute the 119.6 and that's 598. At this point, what you can do is you can combine all your like terms. Since this is the same variable as this, I can add those two together. And since this doesn't have a variable and this doesn't have a variable, I can add those two together. All right, remember we're still trying to find that final temperature. So I'm going to isolate this variable by getting rid of this part of the equation. Since it's being subtracted, I'm going to do the opposite, which is addition. This will cancel out, and whatever I do to one side of the equal sign, I do to the other. So I have 2669, I'm sorry, 20, this should be 226696 is equal to 2631.8 TF. All right, at this point what I can do to get TF by itself, since it's being multiplied, I'm going to go ahead and divide. And whatever you do to one side of the equal sign, you do to the other. And I get a final temperature of 86.1 degrees Celsius. And that's it.